Alright, compound interest. Let's look at this example from the last video again. If we start with $500, after 1 year, 1 year later, we've earned 10%, so we've got $550. Okay, so what we could have done, 10% is 0.1. So what we could have done is we could have times this by 1 plus 0.1. Okay, which is the same as timesing by 1.1. If you take 500 times it by 1.1, you get 550. After 2 years, again, you can times this one again by 1.1. Alright, so after 2 years, we've got 605. Okay, so after 3 years, we can put it in the calculator. 605 times 1.1, 665 times 1.1 is 665.50. And let's say I wanted to find 7 years. So I wanted to skip ahead and find 7 years instead of doing it one at a time. What I could do is it's going to be 500, and I'm going to have timesed 1.1 7 times. Okay. Each year I'm going to times by 1.1, so I've done that 7 times. So I could put this into my calculator. Get 500 times 1.1 to the power of 7. Okay, so I'll have $974 and 36 cents. Alright, so we have a formula for that. And this is the formula, the compound interest formula. Okay, compound interest formula. Alright, A equals P times bracket 1 plus R. Okay, R is the interest rate per period as a decimal. So we had 10% interest in the example there. That was 0.1. So that's how we ended up with 1.1. This is the 1 plus R. So P, again, that's the principal starting amount. And the A is the amount to be repaid, or what it's worth at the end. And N is the number of compounding periods. So I didn't say N is the number of years because we're going to look at, there are situations where you get your interest actually several times a year. Okay, let's look at this. There's different compounding, okay? This is called compounding. So this is compounding periods. Alright, so interest, in the example we looked at, interest is paid annually. That was once per year. Okay. Sometimes interest might be paid twice a year. Alright, in that case you divide your interest by 2. Okay, if you've got 10% per year, that means, and it's paid semi-annually, it's paid every 6 months. You get 10% interest per year, you'll get 5% of it after 6 months, and you'll get 5% of it at the end of the year. Okay, and quarterly, you get 4 times a year, monthly 12 times a year, fortnightly 26 times, weekly 52, and daily 365 times a year. So what you do is, in examples where you have interest that's compounded more than once a year, you have to change your interest rate. Your R is no longer, it's not going to be the same as your per annum interest rate. You have to actually divide by one of these numbers to get a new interest rate. So if you're getting interest twice a year, you divide by 2. If you're getting interest monthly, you divide your annual rate by 12. And also the the number of compounding periods. If you're getting interest twice a year, that means you're going to have to take the number of years and times it by the number of compounding periods per year. So for example, a loan at 9% PA interest, compounded monthly for 7 years. R is going to be 0.09, okay, that's the 9%, divided by, compounded monthly means 12 per year, so I divide that by 12, which would give me 0.0075. And N, in this case, if I'm getting interest monthly, it's going to be my number of years, the number of interest, the number of compounding periods is going to be 7 times 12. Okay, each year I'm going to get 12 interest payments. So that means I'm going to have a total of 84 payments. Okay, so let's look at an example from the textbook, page 718. Okay, Clive borrowed $12,000 to buy a machine for his factory. He's agreed to pay interest at a rate of 15% PA per annum and repay the loan in full in 3 years. So calculate the amount to be repaid if the interest is compounded annually, half yearly, or quarterly. Okay. Anyway, P, he borrowed $12,000. We know that. Okay, we've got our formula here. A equals P times 1 plus R to the N. Okay, so now P is the same for all of these, but the other two letters, the R and the N, are going to be different. Okay, so for the first one, R is going to be, it's once a year, so it's just 0.15, and N is just 3. Okay, for the first one I don't need to do it, because it's once a year, so the numbers don't change. N is 3, because it's 3 years, once a year. Okay, so you just get formula A equals P times 1 plus R to the N equals 12,000 times 1 plus 0.15 to the power of 3 equals 18,250 and 50 cents. Okay, B, half yearly. Half yearly means 2 times a year. Okay, that's semi-annually, half yearly, same thing. So now R is going to be 0.15 divided by 2, which is 0.075. N is going to be twice a year, so it's going to be 3 years times 2 times per year is 6 total payments. Okay, divide R by 2 times, divide the rate by 2 times the years by 2. A equals P times 1 plus R to the N, so that is 12,000 times 1.075, that's 1 plus R to the power of 6. And that equals 18,519.62. Okay, so that's actually a little bit more than if it's annually. We have to pay more money back. Okay, C, quarterly means 4 times per year. So in this case, R is going to be 0.15 divided by 4, which is 0.0375. And N is going to be 3 years times 4 times per year is 12 payments. Okay, so A equals P times 1 plus R to the N. So 12,000 times 1.0375 to the power of 12. Is $18,665.45. So it's gone up again. Okay, so the more times you compound per year, the greater the amount that's owed or has to be repaid. So if this was monthly, weekly, or daily, that number would get a bit bigger. So this is saying it's the same as if we had a loan that was, this is 3.75% for 12 years. Okay, that's basically amounts to the same thing. All right, done.